Okay, so today I'm going to show you a basic demonstration on how to construct the Schmidt plot. Now, first thing that you have to remember is the general formula. General formula states that to get a particular temperature point, let's say T1, you have to add the point on the left, which is T0, to the point on the right, which is T2, and divide that by 2. So let's start here. So to get T1, what you have to do, you have to connect the uppermost point, which is 150 degrees Celsius, to the uniform temperature of T2. That way, we will get the first point for T1. Let's label that T1. Now, some key phrases to remember in this example here. They said that the center of the rubber sheet, they want to get how long it'll take to get to the center of the rubber sheet above 100 degrees Celsius. That gives you a general idea as to what they want, because that center will basically mean you're going to have to get a horizontal line that will be above 100 degrees Celsius. So let's continue. So to get T2, you connect the new T1 to T3. There, we will get our T2. So then we want to get T3. Now to get T3, we go back to 150 degrees Celsius and we construct a line from this point here to the new T2, and we go straight across to get our first horizontal line. Because remember, we're doing that across T3 because T3 is the center of the rubber sheet. And that is what they want. They want to find how long it'll take to get the center of the rubber sheet to reach a temperature above 150 degrees Celsius. So that is why we have a horizontal line here. Also, one thing to take note of. The divisions that you're using, it all depends on you. I haven't tried with odd divisions, but it's best in this case, seeing as how they want the center of the rubber sheet, to go with an even number of distributions. So as you can see, we have 6 even distributions, or even divisions, sorry. So as a result, if you're going with an even number of divisions, you can go with 4 or 6 or even 2. I wouldn't advise going with 2, of course, but you can go with 4, 6, heck, even maybe 12, because the more divisions you get, the more accurate the answer. So let's continue. After going from T2 to T4, you go straight back up to where the 150 degree mark is. And let's label some points here. The first point will be T11, which will be the second time we're crossing T1. Then we're also going to label our first T3 value, our first T3 point, sorry, our first T4 point, as well as our first T5 point. Now, after we do that, notice we have found our first point for T3. So that completes the cycle, basically. We found the first center line, but notice, if we go back to the actual already made example, you'll notice that we haven't even reached above 100 degrees Celsius yet. So we continue. We find T4. To get to T4, which is the average, we have to connect T3 to T5, but it's not that simple. To do that, we have to connect. Remember, we're going with intervals here. So to get to T4, you go from the second T11 point. We go straight down to where T3 is, and we go straight across over T4 to get to T5. Bingo! We have found our second T44 point. After that, we want to find T5. So again, we're going with intervals. So if you were to find T5, which is T4, between T4 and T6, if you were to go to the left in terms of intervals, the next interval to the left will be T2 to T4, and the next interval to that will be T0 to T2. So we go to the very beginning, which is T2 to T2, and connect. Bingo. And we get our second horizontal line, and then we go over T5 to get to T6. And then that's where we're going to get our second T55 value. Now, we have pretty much found everything. Oh, one thing to note, since the Schmidt plot is, as it seems to be symmetrical, what you can do, you can extend, connect these points here, as well as connect these points here. Right, so let's go back to our stuff. So, the question is asking to get a temperature above 100 degrees Celsius. If we were to go back to this example here, the second line is at 80 degrees Celsius. So that means that we have to connect, we have to construct, or we have to obtain 2 more horizontal lines. So if you're noticing the pattern, before we get a horizontal line, we're always getting a V-like shape. So since we got a horizontal line here, the next shape that we're going to get, the next line, will be basically a V-line. So, since we used this construction here to get T55, what we're going to do, we're going to use our new T111 value to get our, well, to get closer to getting our third horizontal line. So after we do T1, we go straight back to where 150 degrees is. We cross over T11 because that's where we used to get our third V line, and we go to T2. We go straight across because remember we're going straight across T3 because T3 is the center of the rubber sheet. We connect to T4 and we go straight back up where T6 is. But if I were to label this line here in terms of temperature, I will still not be over 100 degrees. I'll probably be around 98, 96 degrees Celsius. So we do that process one more time. We connect the new T1111, or you can say T4 value, to T3 and back to T5. Next, we then go back to 150. We cross over T1111 or T4 to get to T2, and we get our last or wanted horizontal line over T3. And we go back up for symmetrical purposes, and bingo. If I were to draw this line here, I would most likely get a line right above 100 degrees Celsius. With that in mind, what you have to do is simply count the amount of lines between T1 and T2. That will be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that will be 9 times, or 9 intervals that we have created. If we did not have to reach the over the 100 degree mark, then the very last point that we would have had to construct would have been this T5 here, which would have meant that we would not have gotten that many intervals. But they wanted to go above 100 degrees Celsius, which means that after we constructed or attained our last line for T5, we had to repeat over the V-line, horizontal line process until this line here was over 100 degrees Celsius. So we then use the formula that we're given, or that we know. We have already calculated the delta theta, which is the time, as well as we know that the number of intervals is 9, So the time it'll take for the center to reach above 100 degrees Celsius will be 9 times whatever temperature that we calculate, and that will give us our answer. So I hope, despite my blabbering and stops, that the basic process has been understood. And yeah, good luck in constructing your graphical Schmidt plot. Take care.